of spot speed studies, which is part of traffic data collection. Okay, so spot speed means what?
Specific spot.
A specific spot. But if I don't have a radar or a speed gun, then I can't do a spot speed study. If I don't have a speed measurement device, a detector, then how do I do a spot speed study? Can I do it using a stopwatch? No? No? I cannot? I can? Because I'm the instructor, I can, right? Yes, I can, but there is a restriction. What was the restriction? Short segment, less than 1000 feet. Okay, and from spot speed studies we get the free flow speed of the drivers, the choice of the drivers, okay, which is without the traffic. Okay, and once you have the spot speed studies, once you have done the spot speed study, you can use it for any of these things, for design, for management of traffic, for setting up the speed limits, and so on and so forth. We discussed some of these terms. Okay, average, we know average. Okay, average also called as mean. And which mean is speed? Time mean is speed. Okay, which one is the other one? Space mean is speed. Okay, then we have a standard deviation, which is the difference between the mean and the other values. Then we have the percentile, okay, which is a value which covers 85% of the data. Okay, and median is also a percentile. Which percentile? You know median, right? 50th percentile, because it's in the middle. Okay, and then we have pace. What is the difference between pace and the other four things? There's one main difference here between pace and the other four things. Pace is a range. All other are values. Pace is a range, and this range has a limit of 10 miles per hour. Okay, so that's the thing. Yeah. No, it's always 10, but the values, the start value and the end value can change. So it could be 50 to 60 or 51 to 61, but it cannot be 51 to 70. Got it? Okay, the difference cannot change. The values can change. Okay, for speed data collection, we already discussed some of the things, right? Like you can collect using a stopwatch, you can collect using a radar, you can collect even with pneumatic road tube. We mentioned that you can collect it using pneumatic road tubes. Okay, we did not discuss how, but we can. Okay, but a very commonly used device for speed data collection is a loop detector. I mentioned it in the previous topic as well. Where do we use the loop detectors? Near traffic lights. Okay, and using loop detectors you can change which time of the signal? The yellow time. Okay, so this is how they look like. This is why we call them loops. Okay, you can see it's a loop, right? So the car passes over the first part, the second part, and it will calculate the speed. Okay, and it has obviously a distance from the signal and so on. And other things we already discussed. Okay, we have a speed gun, by the way. I forgot, but I will try to bring it in the class. It's an old speed gun, so you will know what it looks like. But it's very old. I bet it's not working, but nothing works. Okay. Now about speed data collection. So this is why we need to finish this topic so that you can do the second part of the term project, because it's not the same as what you did in the first part. Okay, so in speed data collection we divide the data or values into speed groups. They call them speed groups, basically intervals. So like your grades. So A is an interval, right? and A minor is an interval. Okay, you know the biggest interval in your grades? Which grade has the biggest interval? Goes from 0 to 60. Oh, sorry, 0 to 59.9. Thank God. Okay, but so speed is also divided into intervals. Speed data is also divided into intervals, and these intervals are called as speed groups. Okay, so you don't write values, you don't need values for calculations, you need speed groups. Okay, so you will have group, the interval of the group, and the number of values in that group. For the exact value of each entry is not required. Okay, so for example, I say I have 20 students having an A. Okay, so you know the range of A, and you know number of people who got in this range. But maybe out of those 20, one of them got 99 and the other one got 91. But all of them are in the same group. Same thing with the speed data. Okay, now we are talking about from the perspective of calculations. So yeah, you go there with a speed gun or with the app which can measure the speed, you will get values. Yes, you will get values. But in the end, from those values you will make groups. Okay, and you will put the values in those groups. You will count the number of values for each group. Okay, something which you can see over on this table, in this table as well. So the first two columns, I'm sorry, you cannot see it, should be bigger, but the first two I'll show you in the next slide. It's there. Or let me go to the next slide. So you see the first two columns are speed groups, are showing the speed groups, the range of a speed group. So the first one starts more than 30, goes up to 32. Second one more than 32 goes up to 34, and so on and so forth. How many values in each group? This is the. Okay, so you need these two things and this one to do the calculations. Got it? So speed data must be divided into groups, and then you need the number of values in each group. Clear? So even you got the data using distance upon time, or using a speed gun, or using a loop detector, whatever. In the end you have to do this. You have to divide the speed data into groups, and you have to put the values according to each group, number of values according to each group. Clear? Okay. Now how big should be these groups? We already mentioned the grades. So one grade has a very big range which we don't like, and the other grade which we like very much also has a very big range which is A. Okay, but the other grades are, so the range is not common. The size of the grade is not common, is not constant, but speed groups must have a constant size. You cannot make the first group from 30 to 35 and the next one is from 35 to 36. No. If the first one is from 30 to 35, the second one 35 to 40 to 45, they must be constant. The group size must be constant. Okay, 2 miles per hour is considered as a optimum size. 2 miles per hour is considered as an optimum size, a good size. Okay, which I just showed you in the table as well, right? It was 30, 32, 32, 34, 34, 36. This is considered a good size. Okay, but it's not fixed. You can have 3 mile per hour size as well, 1 mile per hour size as well, but it should not be more than 5. So 5 is maximum. Don't go above 5. Less than 5, if you can make it with 2, very good. If you cannot, you can change it, but don't go more than 5. Clear? Okay. Now for your projects, you have to make a size so that you have at least 5 groups. You have at least 5 groups. So you have to look at the maximum value and the minimum value, and then select the size, so then you can have at least 5 groups. Why? I will tell you later on when we do some calculations. Clear? Okay. Okay, one more thing which you should keep in mind, that why we change the group size. So for example, somebody says if 5 is maximum, I will take 5 always. No problem. But if your data is very small, what will happen? All values can be in one group. If the maximum speed and the minimum speed are within 5 miles per hour, all of them, then you will have how many groups? 1. So the group size should change according to the range of data. Okay? The data has a range from 50 kilometers per hour to 100 kilometers per hour. Yes. You can make a bigger size and still you can have 5-6 groups. That's good. But the minimum is 40, the maximum is 48, and you are taking a size of 5 miles per hour, everything is covered then. Okay? But that's why I said play with the size, at least you have 5 groups. Look at the minimum, look at the maximum, divide it equally so that you can have 5 groups. Now what is written here? What they are showing in this table. You can see there's nothing to see basically. These are just lines. Okay. When you go and count in the field, you make these lines. Okay. These are called as tally marks. Okay. Tally marks. Okay. So these are just lines. So when you go in the field, now you're counting cars, for example, counting vehicles. And you count 1, you write 1. You count 2, you write 2, and 3, and 4. You reach up to 9. Then the next number is 10. How many digits? 2 digits. You count up to 99. Then you will write what? 100. How many digits? 3. The number of digits are increasing. Your work is increasing, right? The value goes up to 1000. Now you are writing 4 digits every time. Okay? So we don't want this. Because the cars are moving, right? They are here for some time. We have to make sure that we don't miss anything. So we write, let's put lines. We'll take these lines to the office, we'll count them, that's it. We'll count the lines, that's it. Okay? Now, in writing these lines, they make sets of 5. So the counting becomes easy. So they put 4 vertical lines, you can see here. Like there are 2 lines here, 3 lines here. Okay? So if there is a 5th car or a 5th vehicle, they cross these 4 lines, which you can see in the first 2. So there is a line crossing that. So crossing line means what? It's a set of 5. Okay? 2 crossing line means 5 plus 5. 3 means 5 plus 5 plus 5. Got it? Okay? They make sets of 5. Okay? I saw another method by one of our colleagues. You know Professor Mustafa, right? Okay, he showed it to me. Maybe it's a Turkish method. So what they were doing was, they were making boxes. Instead of lines, they were making boxes. So 1, 1, 2, 2, 3, 3, 4, 4. Box complete. Now you had to make a set of 5, right? So you 5. Okay, this also works because we are just making lines. Okay, but obviously every line is in a new direction, so it will make it difficult. Okay, so this is how we do it in the field. Clear? Just make vertical lines, and every 5th line is a cross. Clear? Okay, then you come to the office and just count the number of lines and crosses you have made. Okay, so 2 crosses means 10, and then there are 2 lines, so 10 plus 2. Total is 12, right? Got it? Okay. So you did you had the lines and you make the speed groups and you collected the data, and this is the table which you have to work on later. So the first two columns I already mentioned, right? The speed groups. Okay, the speed groups. The third column comes from the first two. This is average or the middle, whatever you call it. Okay. You made the speed groups, right? Looking at the data, the minimum, the maximum, again you come guidelines, right? Okay. The maximum interval between the groups should be how much? 5, not more than 5. Okay. But you make the group. Once you make the group, you can calculate the average, right? No problem up till here. Then, how many values in each group? How many values in each group? Okay. How many cars you observed in each group? Okay. So it's not fixed. You have to observe it and you will put it as you observe. Okay. So in this group they did not observe any car. So 0. In this group they observed 5. In this group they observed 5. And so on. Got it? Clear? These values are not fixed. Nobody is fixing them. Not even the engineer who is doing this survey. It is as per observation. Got it? The fourth column is as per observation. No calculation here, no assumption here. Got it? Clear? Okay. The rest of the 4 columns are calculated. The first column is percentage in each group. They call it percentage frequency. Percentage of values in each group. So you have to do the total. Total is 368. Out of 368, what percentage in the first group? 0. What percentage in the second group? How did I got 1.36? 5 divided by total. Okay, so number divided by total and percentage. Clear? Okay. Then cumulative percentage. It comes from the percentage, right? So you add them. You add them. So first one obviously 0. Second one 0 plus 1.36. Third one 0 plus 1.36 plus 1.36. There. So every time just adding. Last one will be how much? 100. Always?
Yes.
If you do this, your grade will go like this. Obviously, the last one has to be 100, right? Okay, the last one has to be 100. Even after doing this, 100. Okay. Next one. Now look at the columns. Which column is N? Which column is N? Number of values. Observed number of values. Okay. And which column is S? Capital S.
The middle speed.
Look at the columns. The middle is speed column. Okay. You see S mentioned here, N mentioned here. Okay. So N into S means multiply these two columns and this is the value. And N into S square means N multiplied by the square of column S. Clear? Okay. So we calculated the percentage. We calculated cumulative percentage. We calculated number of values into middle speed. And we calculated number of values into square of middle speed. Okay. And for each column we did the sum. We did the sum for N. We did the sum for percentage frequency. Cumulative obviously means sum. We did the sum for N into S and we did the sum for N into S square as well. Clear? You are adding all the percentages, right? So, if I add the percentage of everybody, cumulative is 100, right?
That's why the last one.
I have, for example, I have 10 VD. Okay? For example, don't ask me for. Okay? and I distribute them equally among you. Okay, so each one will have, for example, 10%. For example, if I add 10%, 10%, 10%, 10%, I add all of them. How much will I get? In the end. So this is the total, and from total, this group has this, this group has this, this group has this. So if you keep on adding them, in the end you will get 100. This is out of total, right? So if you add all of them, you will get total. Clear? Any other question? Where to use these columns? Now we will talk about that. Okay? But the table is, you understand what we have done with the table. Okay? The first two columns, we set them. According to the first two columns, the middle speed will come. The fourth column, observation from the field. I did not do anything with it. Next column, percentage for each group. Next column, cumulative percentage. So I just add the percentages. Then the next column, the summation, the multiplication of third and fourth. Okay, and the last one, the multiplication of square of third and the fourth. N into S square. Okay. Then I plotted the frequency, the percentage and cumulative percentage in these graphs. And from these graphs you will get many values. The first graph, on the x-axis I have middle speed. Third column, middle of each group. On the x-axis. On the y-axis I plotted percentage frequency. 0, 1.36, 1.36, these values. Clear? Okay. Then next graph for cumulative percentage frequency. On the x-axis I plotted upper limit of each group. Which column? Second column. Okay, so it starts with 32 and 34 and so on. Okay, on the x-axis. On the y-axis, cumulative percentage frequency. Okay, so 0, 1.36, then 2.72, 4.62, these values. On the y-axis. The first graph, these values. Second graph, these values. Okay, first graph on the x-axis, middle. First graph and second graph on the x-axis, upper. Okay, so both graphs have different values on the x and y, both. Got it? Clear? Okay. Just a couple of things. You can see the points are plotted and then they made the curve, right? Is the curve joining all the points straight? No, right? We call it best fit curve. We call it what? Best fit curve. The curve, a smooth shape which is closest to these points. So you can see both of them are smooth curves, right? If you join all the points one by one, it will look like a zigzag line. Just look at the first graph, the top one. Even if you try to join 2-3 points at the start, the line is going up and down, up and down. Okay? So what do? We make a smooth shape which is close to these points. But if any point is ruining the shape, destroying the shape, we ignore it. Look at the second point. First graph, second point. Is it on the curve? No. Why? If you try to join it, your curve will be distorted. So we ignore it. Okay? So best fit curve is a smooth shape which is closest to the points. But if any point is ruining the shape, ignore it. Clear? Okay? Both cases. This is done in both cases. But obviously the second curve is more smooth. So all the points are actually, they look like on the curve. but this is what is done. You can do it manually. We used to do it manually. Just ask any architecture student, he will do it for you. Okay, but any software, MATLAB, Excel, Minitab, pick any software, all of them can do it for you. Best fit curve or best fit plots are given with any software which is used for plotting the graphs. Okay, no problem. Clear? Okay, but you need to understand the concept. What is the concept? I'm trying to be close to the points, but at the same time I want a smooth shape. Got it? Clear? Okay. The next thing about the curve. Both curves are starting from which value? 0. Both of them are starting from 0. The first curve ends where? 0. The first curve ends at 0. And the second curve ends at 100. Okay? Now, we did it intentionally. We set the data so that we have 0, 0 for the first curve, start and end. And we set the second, or we set the data so that we have 0 and 100 for the second curve. We did it. How? Look at the data. How many values in the first group? How many values in the first group? N. What is the n in the first group? 0. What is the n in the last group? 0. So why did I start from 30? 30, right? Why did I start from 30 if there were no values? I could have started from 32, right? The minimum value was from 32 onwards, right? There was no value less than 30. That's why that group has 0. And I could end at 66. Why did I go from 66 to 68? I made it, right? If I leave this group, the last one, will it affect my data? Will I miss any data? No. If I leave the first group, will I miss any data? 0 values, right? So even if you take these groups out, no problem, right? Okay? But our curve will be in the air. It will not meet the axis. Okay? So you have the minimum value, you have the maximum value, you make the groups. After you make the groups, add another group extra which will have 0 values. And same thing at the end as well. After the maximum value, make another group extra which will have how many values? 0. So the curve will start from 0 and end at 0. Okay? Got it? So after I collected the data, made the speed groups, I made 2 extra groups, one which will have 0 values at the start and the other one which will have 0 values at the end. So the graph will start from 0 and end at 0, the first one. It will start with 0% values and end with 0% values. And the second one will start from 0 and end at what? 100. Okay, second one will always end at 100. It's cumulative, right? Clear or not? Any questions? Clear? Okay. From the speed data or from any data, you can calculate 2 types of statistics, 2 types of values. Okay. These are called as descriptive statistics. Statistics or values which describe the data, which tell you about the data. Okay, what type of data I have. Got it? Descriptive statistics means the values which tell you about the data, the type of data you have. Okay, so these values or statistics can be of 2 types. We have central tendency and then we have dispersion. Values or statistics which come under central tendency, they tell you about the middle of the data. Where is the middle of the data? Okay? The data is centering around what? What is the center of the data? Dispersion. The statistics or values of dispersion tell you about the variation in the data from the center. How far are the values from the center? Okay? Clear? Values about the center, that is central tendency. Values which tell you the variation from the center, that is dispersion. Got it? Clear? Okay, so these are the two types of descriptive statistics. Statistics which denote the type of data, which tell you about the type of data. Okay, we will look at each one of them, it will become much more clearer. First statistic of central tendency is mean. Mean is what? Center, right? Mean is a type of center. It's usually around the center. Got it? Okay. So for mean, you do what? How do we calculate mean? And total divided by number, right? Total divided by number. Okay. So number is number of cars for which you took the speed data. Now total of what? Total of what? Now remember, I am calculating, this is speed data, right? The data is for what? Speed. So I need what? Average of or mean of speed. Okay? What I am putting in the denominator? Number of cars, right? So in the numerator there should be something about speed, right? But which speed? Remember, what did I do with my speed values? What did I do with them? I made them into what? Ranges or groups. We call them groups, intervals, but you get the idea, right? The data is divided into groups. Each group has its own values, right? One group has 0 values, another one has 5 values. Okay, so each group has its own value. Okay, so you cannot do simply summation of the values upon number. Number is number, I know. My total number I know. But which values are divided by the number? For that we calculated the n into s column. Remember this column? So summation of this column divided by number. Okay? Summation of n into s column divided by the number. Got it? Okay? This is called as weighted average. Weighted average. The one which you are seeing is a simple average. When you divide by the number with the values, it becomes weighted average. Okay, this is what we did in this column, right? N into s is what? Number into value, right? N is number and s is a value. Okay, so we call it weighted average. Whenever you do this something like this to calculate the mean, we call it weighted average, not simple average. And if you do summation of values divided by number, simple average. Got it? So here we are doing what? Weighted average. Okay, so summation of n into s divided by total number. Okay, so summation of n into s is given here 17,736 and the total number is 368. Okay, so this divided by this will give you the mean. How much is it? How much is the mean? Tell me.
48.116.
How much is it? 48.1. Oh, it's not. 0.2. Okay, did you get it? Okay, Why did we take the weighted average? Because every group had different number of values, and we had data into groups. We didn't have the values. Got it? Okay. Any question? Okay. Other measures of central tendency include, the first one is, where should I start with? Median. Okay, fine. We start with median. So median was middle value, right? Okay. Middle means it covers how much data? What percentage of data is covered? 50%. You come to the second graph now, the one which had the cumulative frequency. Okay, so you said median is at what frequency? 50%. Come to this graph, look at where is 50%. You can see it here, right? Okay, from 50% draw a line to the curve and then drop the line on the speed axis. This value of speed is your median. Clear? Okay, median is 50%. So I will go to 50% on the cumulative frequency. Drop perpendicular on the curve and find out the speed. This speed is my median speed. The speed which covers 50% of the data. For this data it is 47.7. So half of the data is below 47.7 and half of the data is above 47.7. Got it? Clear? Next, so median is in the middle, right? Median is the middle. So we call it central tendency. It's a measure of central tendency. Mean was a measure of central tendency. Median is a measure of central tendency. Another measure of central tendency, mode, not mode. Mode changes. Mode doesn't. Mode means what? The mode value of a data. Can we guess? Most repeated value. Do we have values or groups? Groups, right? Okay. And do we have number of, and each group has what? Frequency, right? Each group has frequency. And each group had a central value, right? Each group had a middle value. So mode will be the middle value which has the highest frequency. Now where is the frequency? Tell me. First graph. The second graph is cumulative. The second graph is cumulative. So I am not talking about cumulative. I am talking about for each group. Okay. So you go to the first graph. Okay. Look at the middle speed which has the top frequency. Okay. So it's very simple. You have a curve in front of you. Go to the top of the curve. Drop a perpendicular on the speed axis. This is your mode. Got it? How much is it? 47. For this speed data, the value 47 has the highest frequency. So this becomes the mode, the most repeated value. Clear? Clear? Okay. The last measure of central, so mode you can see. Now you may say the most repeated value can be the highest one or the lowest one, right? It can be. It can be. Okay, but usually it is not. Usually the mode is around the center, around the average or the mean. So that's why it is under central tendency here. Okay. For example, let's say if I take the data for the grades. Okay, the mode can be the lowest value. The mode can be the lowest value. Very good for me. And the mode can be the highest value. Not good for anybody. They will call me and say, what's happened in your class? Literally. They will call me. What did you do in the class? Okay. So, but in the speed data, the mode is usually in the center or around the center. So that's why it's here in central tendency. Okay. Now the last measure of central tendency is pace. Pace. Now remember, pace was a range. Pace is a range. Okay. For pace, I'll go to the first curve. Okay. Now the distinguishing factor about pace is it has comparatively highest proportion of drivers. It has comparatively highest proportion of drivers. So if you go outside the pace range, the proportion will be less. Either you go outside on the higher side or outside on the lower side. Okay. Now if you come here, look at the first graph. If I ask you where is the highest percentage of drivers, where is it? In the middle, right? Or near the top of the curve, right? It's near the top of the curve. Okay. So what we do? We make two lines around the center. Two lines around the center. The difference between these two lines should be the range of pace. The range of pace is always how much? 10 miles per hour. Okay. So you have to set up two lines around the top of the curve, and the difference between these two lines is always 10 miles per hour. Okay. And then you look at how much is the speed under these two lines. For this case, it is how much? 42.5 and 52.5. For this data, the pace goes from 42.5 to 52.5. Got it? There is another way to do it. If you have the graph in front of you. Okay, so I printed the graph. Okay, so instead of drawing the lines, you can take a scale or a piece of paper or any cardboard or anything. Okay, cut it so that it is equal to 10 miles per hour on the graph. So the graph has a scale, right? This graph, when you plotted it, it has a scale. When you printed it, it has a scale, right? So let's say according to the scale, 10 miles per hour is equal to 3 centimeters or 2 centimeters, let's say. Okay? So you will cut a piece of paper or you will cut a scale which is equal to 2 centimeters. So if I put this scale on the graph, the speed under the scale is always 10 miles per hour, right? According to the scale. Okay? So then I put that scale or that piece of paper in the around the center of the curve or around the top of the curve. Okay? And wherever the piece of paper or scale is touching the curve, the speed under that is my pace. So either you can draw the lines if you are doing it on a screen, or print the graph, have a piece of paper which is equal to 10 miles per hour and put it in the middle. Wherever the piece of paper touches the curve, you look at the x-axis, what are the values? Ruler, yes. Got it? You get the idea? Huh? Clear? Any questions? Okay. So measures of central tendency finished. Okay. We will discuss only standard deviation today because we already have the values. Or not. Okay. So, who did not mark the attendance? You can do it with the card as well. There's an option for scan by card. Okay. So, standard deviation is the difference between the average difference between the average and the rest of the data. Okay. If there is no option to scan by card, then you can do it by the phone. Okay. So you can see there are two equations for calculating standard deviation. One is this one which we use with normal data, and one is this one which we use with the group data. Our data is normal or grouped? It has groups, right? It has groups. So we'll use this equation. Done? Because of time. I'll do it. Okay. Focus here. Okay. So we have group data, right? So we'll use this equation. Okay. What was n? Huh? What was n in the data? Number of vehicles in each group. Number of vehicles in each group. What was s? The middle speed of each group. X bar you just calculated. The average or the mean. Capital N is 368. What was 368? The total number. So small n is for each group. Capital N is total. Got it? Clear? If you open this bracket, multiply n with this, okay, and do everything. This is a simplified form of the same equation. This one is a simplified form of the same equation. So there are only two equations. This one for the normal data, this one for the group data. If you simplify or you open the bracket and you simplify it, it will become this one. Okay, so you can see n into s square as it is. And then this is what? Capital N into x bar. If you do summation of n, it will become what? Capital N. And x bar as it is, okay, and then n minus 1, okay. So which equation we are going to use? This one, because we have group data and you obviously want to use a simplified equation, okay. Now for this equation, do I know capital N? Do I know x bar? Do I know n into s square for each group? And they did the summation as well for us, right? So give me the value for standard deviation. This is the equation. Somebody got the card, right? You gave the card to you? Yeah. 6.1. Any questions?